Okay, we are back. Okay, let's start now. Okay, so let's go to that screen again so that you guys can continue reading. Okay, look what are good and poor conductors. Carry on. Then the next slide shows you this, and then the next slide shows you this. So you must know roughly what we are going to talk about. Am I right? How many of you have not done this lesson in school? It doesn't matter because this is something that you come across at home even. You are taught not to touch hot things, especially stuff on the stove, in the iron, in the room, and stuff that are made of metal that get very hot. They definitely can SCALD, scald you, right? What is called? Okay, burn you, okay? So go back to the pointers and read through together. When two objects touch each other, heat flows from the hotter object to the colder object. Some materials allow heat to flow through them. They are known as good conductors, and if they don't allow heat to pass through them, they are known as poor conductors. So you have to also know how to write them in English with proper grammar, proper sentence, not just know that, oh, this is very hot, it can burn me. Mommy, it's hot, it's burn me. Okay, but why it burn you? What material was it made of? Is there a reason? Why when wood is hot, it doesn't burn you? What's the difference between wood and metal, and so on and so forth? We will be asking you to share with us later. So from the pictures, you can see what's happening here. And I'm going to add more pictures, and then you're going to see what did we do to not burn the two hands that you see. Can you see the two hands? One on the left, one on the right. Am I right? What can we do? We can use a cloth and hold the pan, which we do normally. Or some of us are more sophisticated. We go out there and buy these oven gloves, which are, why are they called oven gloves? Especially when we want to take things out of the oven. What is the material that makes this oven glove not able to burn our hand or scald our hand? There must be something between our hands and the pan to protect us, that fabric. Okay, it can't be just fabric, it must be a special type of fabric. What is it? Okay, so air is a poor conductor of heat, so you should have a lot of air pockets inside that fabric. Okay, wool is a poor conductor of heat, so maybe you should have a lot of wool inside that kind of fabric, not really cotton. Cotton is like, if you take any piece of cloth, you hold it, it still passes heat very quickly, and then you feel the heat very fast. Then you're like, oh, no, this piece of cloth won't do, right? Then you change the cloth. Why do you keep changing the cloth until it doesn't burn your hand? You see this lady or man who's holding the pot with some thin cloth is going to definitely burn her hand if the cloth is very, very thin. So you get the idea, okay, how to protect ourselves from heat conduction. So heat conduction, is it always a bad thing? Those of you say bad, type bad. If it's good, type good. If it's good and bad, type good and bad. Is heat conduction good or bad? Okay, I've not seen one answer that's good and bad. It's only bad, 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 good, good, good. What about good and bad? Okay, it is bad because it's going to burn our hand, the heat. But it's good because it's going to help to cook our food. The whole pan, the idea of the pan is to receive the heat from the flame and pass it to the food. Okay, we can't put food directly on the flame, can we? Oh, this thing is happening again and again. Yeah, okay. We cannot put food directly on the pan, right? So we have to have a heating conductor to pass the heat from the fire to the food. So it's actually good, but it's bad for our hand. And so there's a good and bad, and we need to know how to make use of good and poor conductors, and exactly why the so-called pictures in front of you are made of not just the one material, but they're made of two materials because of the good and the bad. The good part is to where you put the food. The part where it's poor conductor is where you put your hand. You don't use your hand and put on the other part, right? So there are two parts. You have to know where to put the foot. You have to know where to put your hand. Otherwise, something's gonna go really wrong, okay? Something's really going wrong with my slides today. Not behaving, just like you all have technical fault, I also have technical fault. Okay, so this picture is familiar as well. All of you have put this item into your mouth. How many of you like to eat this thing? What thing is it? ICE, ice cubes. If they are in your hands immediately feel cold. Okay, not everybody loves to eat that. I don't, okay, but some of my friends do. Some of them love it from young, especially if you are children. If you have been eating it since as a child, you tend to love it till you are an adult. Anish, I like to eat. Jarek, I like to eat. I tell your mommy. Daddies don't bother, right? Mummies always like to tell us not to eat ice. Why? Why is it bad to eat ice? Have you ever want to find out? What does it do? Okay, to your body. Okay, you're actually putting a very cold object that is at 0 degrees into your body. Of course, I also receive some messages here say, hey, my mommy doesn't mind, my daddy doesn't mind, because secretly your mommy also loves to eat ice. That's why she doesn't mind. Because as a child, she also liked to eat, and until she's become an adult, she still continues eating. And then, of course, she's not going to mind because she does it too, right? Okay, so that could be the reason. Maybe you should catch her eating it without your knowledge one day. What else? Okay, like I said, it's a really, really cold item. So if you're going to put it into your body at 0 degrees, and your body is at about room temperature, 28, 30, or even 35. Okay, usually it's quite warm. Remember, you take your body temperature. What's the temperature it shows? What's your body temperature normally? 36.9, 37. When you get a fever, it's 38. Between 38 to 0 degrees, that's a huge jump of temperature. That's why we drink water at room temperature. If we drink ice water, it's bad for us because something happens to your body. Okay, there's a very quick transfer of heat between your organs and everything that is inside your body to the ice or the cold water, and therefore it goes haywire inside your body, and then you get sick, and then these germs come out to play. Okay, so that's what's happening. This heat transfer thing is a bad thing for our body because our body's temperature is really, really high. It's different. Okay, don't tell me. Okay, some people have the misconception that if you go out to a cold country, your body is cold. No. In fact, your body actually becomes warmer because it tries to prevent itself from getting cold. So it will adapt. So it actually becomes warmer. Okay, your body's temperature does not drop. The body's temperature is universally the same wherever you go, or it even becomes slightly warmer internally to protect yourself from the cold environment outside. So that's the amazing part of your body adaptability. And all of us will be learning adaptations to the environment very, very soon. Okay, as you go to P5 and P6, there's this chapter on the environment where you will learn how humans adapt, animals adapt. Remember, you have animals who survive the cold, like polar bears. How do they stay in that super, super snowy place for so long without anything happening to them? How about penguins? How about bats? How come they can stay inside the caves for so long without light? What is it about their eyes that can make them see? Or is it because they can hear? Can they actually are able to manage to find their way by hearing? Do you know that? It's called echolocation, and so on and so forth. This is P5 and P6. Do you know another interesting fact that we actually took out this topic for this year's PSLE? Well, you don't know because you're not sitting for a PSLE. So PSLE friends who are 12 years old going, they unfortunately are not going to be tested on this topic because they have missed out so much due to COVID. But possibly their science teachers will still teach them. Okay, not to worry, we will teach everyone the same thing so that you have knowledge about environment. But we will not be so harsh as to examine you because you're not really prepared. You didn't give it enough practice because of COVID. Okay, so PSLE students are going to have one topic less, but not you guys. You guys are not as lucky. You will have the same PSLE syllabus when you get there. Okay. Right, let's go through the next slide. Okay, enough talking about pictures. We should go through the questions also to find out how to answer the questions. Okay, this is a group of products that you may have at home. It's called Tupperware. Many of you may know. Your mommy says, bring the Tupperware, Tupperware. Do you know that the name of this object is not Tupperware? The brand is Tupperware. It's just like, it's so famous that people started calling it Tupperware. You know, like toothpaste. People say, bring the Colgate, bring the Colgate. But in fact, they are trying to tell you, bring the toothpaste. Colgate has become so famous that when you ask to bring even some other brand like Dali or some other Sensodyne, they still say, bring the Colgate, especially the oldies or our grandparents, they like to say bring, because they only knew Colgate. And same way, we are very used to this word called Tupperware. It's actually a brand that's so famous, made this stuff. What did they make, actually? What did they make? Container. What is this so special about this container, Joshua? Joshua, what's so special about this container, Joshua? Joshua, you want to tell us, since you know it's a container? How about Rushita?
Could you repeat the question again?
That what is so special about these objects that you see in your pictures right now?
You use in your everyday life,
Mm-hmm.
and this is a poor conductor of heat.
Very well done. That's the beautiful answer that I was looking for. Okay, it's a poor conductor of heat. Thanks, Rushita. That's exactly it. Because heat cannot go in, because actually the environment is very hot. So remember, you bring grapes, you bring strawberries, and you want to keep them cool, right? Not suddenly turn warm. And then once they're warm, they become mushy, and it's just not so nice to eat after that, right? So they actually prevent the heat from going in. But do they prevent the heat from going out as well? Imagine you have a hot banana cake inside or some rice inside. Okay, it's hotter than the outside. It also keeps it from getting cold. So it prevents heat from going in and prevents heat from going out. So therefore, this is the property of a poor conductor. So let's see what's up next. This is some images of good or poor conductors. Tell me in the message if you can. I have 6 items here. Which of them here are good conductors? Which of them here are poor conductors? Any idea? Poor conductors, everything. Katrina Chain, thank you so much. Poor conductors, everything. Yes, Katrina was the first to tell me that everything here is a poor conductor, especially worn during cold seasons. We don't have them here, unfortunately, in Singapore, but when we go overseas for our travels, and if it's cold, especially we've been to Korea, Japan, US, Europe, these places, Australia, they have cold seasons and they have summer seasons as well. And during summers, we're not going to wear this, right? We're going to wear it during cold to prevent. Remember, I said it's going to be really cold. Our body will change our temperature by a bit, but not so much to be able to protect ourselves from the cold. Okay. So what do? We bring with ourselves an armory and equipment to actually keep ourselves warm. Okay, these things prevent us from losing heat. It does not prevent the cold from entering us. It prevents the heat from going out. Why? Because heat flow can only go from the hot to the cold. Remember this part? This is where we catch you up and we ask questions. Usually students forget that we actually did this before, and they'll probably say, oh, it's to prevent us from getting cold. But actually it's to prevent the heat from escaping your body. It's the same thing, but to write it down in scientific fact is to prevent heat from escaping. Therefore, the heat will be retained and you don't feel so cold. Otherwise, the heat will escape your body faster. Okay, it's not prevent the heat from cold from coming in, because cold doesn't go in. Cold doesn't move. Heat moves. Heat flows. Okay, take note. Okay, that is the most important part. Okay, that's what I wanted to highlight for that part. And then we have those materials that these things are made of are coming from natural resources like our animal friends. Okay, don't think we are harming them. We are actually cutting their hair for them. Okay, we go to the barber, we don't say, hey you, I'm going to charge you for cutting my hair because you have harmed me. Okay, I'm going to report you to the human rights violation. No. Okay, the hair is for us to keep trim. Okay, we keep it short to make ourselves comfortable. It's the same way we do that for the sheep as well. So in actual fact, it's not as harmful as taking leather from a crocodile, because we actually kill the animal to get the leather. But in terms of the sheep, we are still fine because their wool will grow back and they're actually very happy to get their wool sheared and make them comfortable. Just like our dogs, right? We bring our dogs to the pet shop to get them groomed and so on. Okay, so it's fine. Okay, so please take note of what is right and what is wrong in terms of animals. Whatever you do in the future, please do not harm any animals. Very important to know, as well as the environment, which is the whole essence about this science thing. Okay, in primary 3, primary 4, we introduce you to science, but throughout your science journey, you are all about with the science around us and how to take care of the science in order for us not to harm it in any way. Well, not to say we have not already harmed it, we have harmed it in many, many ways. But when we study how people harm it, we actually become aware and we try to stop that. Okay, so that's why we need to go to school and study. If you're not, we're sitting at home just harming the environment, we don't know what's happening. Remember, one insecticide, you spray your cockroach like that. So much CFC is carbon, okay, CFCs that are released into the air. Okay, chlorofluorocarbon. CFC stands for chlorofluorocarbon. These chlorofluorocarbons actually attack our ozone layer, and the ozone layer is getting thinner and bigger holes, and then UV passes through because the ozone layer was supposed to protect us from skin cancer. Okay, all these UV rays are very harmful to our skin. But then we ourselves are destroying this ozone layer by the use of chemicals and human-made products that are damaging them. So we get smarter, we understand this ozone, we understand what is CFC, then we start to make our products better, we start to make things that do not have CFCs, we start to improve. So people learn science to be able to understand what we are doing to the world and what the world is made of, what is it all about, and then we try to improve and make sure we do not harm it. Okay, just yesterday I was reading this article about Nespresso. You know what's a Nespresso? How many of you know what is a Nespresso? It's a coffee machine. You might have seen it whenever you've been to a shopping center, Robinsons, Tangs, and whatever. Some of you may have it if your parents love Nespresso. Yeah, Nespresso. Did I say anything? Nespresso, right? There are a lot of other coffee machines as well with other brands. Like I said, you see, I remember we talked about Tupperware being a brand, and then now Nespresso is actually a brand. It's not the only coffee machine in the world. We have brands like DeLonghi, we have even Philips, we have every brand. But Nespresso is so famous, so everybody call it Nespresso, and they like, oh, that's a coffee machine. But Nespresso is different from a lot of other coffee machines because they use capsules, right? And these capsules, this was invented in 1980s, and it became famous. Immediately it hit the market like that, and they became rich. Because those capsules you put into the coffee machine, it makes coffee for you instantly in like 10 seconds, compared to in a coffee shop where they do it traditionally, it'll take you at least half a minute to a minute. But when they made these capsules, they did not take into account that the material that they're using to make these capsules are actually harmful to the environment. Okay, because if you see the capsule, there's a plastic black color which contains the coffee, and there's also some aluminum cap on top of it, which has to be very hard so that it can pierce through and push the coffee through or the water through for our coffee to come out. And then soon, environmentalists were blaming Nespresso a lot because they say, when we throw these Nespresso capsules away, this aluminum does not get recycled properly, and they pose a big problem in the land, okay, disposal, and it becomes a big, huge problem, cannot be recycled. When things can't be recycled, we call them non-biodegradable. Biodegradable, okay, this is all extra information. I just like to talk a bit more so that you guys learn science the way I do, okay, to be aware of the environment when you read. So if it's non-biodegradable, it means things that cannot decompose on their own. That includes plastic bags. So plastic bags are another harmful stuff. That's why nowadays you go to NTUC, they start charging you for plastic bags because we want to reduce the usage. Why after so many years? Because we learned that they are posing a huge, huge problem, not only to environment, in a circular cycle. they actually affect humans as well, because we are the ultimate patrons or living human beings and living animals of this planet, including plants and other animals. All of us have to live together under this planet. We cannot run away. Can we go to the moon and say bye-bye, I'm leaving this place, you guys are so harmful, this planet sucks, it's a harmful place? No, we have to live here, and we have to make this place a better place for us so that we can survive longer and not affect ourselves. So whatever we're doing, please take note what you are doing. Okay, I started with the sheep and I carried on and on and on until Nespresso. Okay, but it's still a good lesson. You can still share with your friends this kind of information because you know more than them now. Right. Good conductors of heat. This is the final slide. Okay, I think it's final or second last slide before we go to the questions. We have good conductors of heat versus poor conductors of heat. I just list them down for you. All of them is their inherent property. That means they work this way. Okay, metals usually are good conductors and poor conductors like air, fiberglass, cotton. So whenever you need some material that has to be a poor conductor, you know what to pick up. You need a good conductor of heat, you know what to pick up. If I ask you to make a pan to make food, you know what to take. If you are in a forest, stuck in a forest, you've just caught a fish from the pond or the river, and you want to cook the fish, you need to put it on something before you put it on the fire that you just made. Okay, so you need to know what can make the fire, what can heat the fish, what material should I go and source. Should I get silver, steel, gold, aluminum, brass, or should I get a wooden plate and put it on the wooden plate? Okay, so now that's the trick, right? So when to cook, you use a good conductor, but to eat, you try to use a wooden plate so that it does not transfer the heat straight to the plate. You want the fish to be kept hot for as long as possible, and so on and so forth. These are the reasons why we have a selection of materials versus poor conductors versus good conductors of heat. Some of you may ask, what about, I hear the word conductors used for electricity as well. Okay, do not confuse yourself with electricity. We call a conductor of electricity a conductor as well, and an insulator as well. A poor conductor, another name for poor conductor is called insulator. If you have seen this or come across this word called insulator, it's nothing but a poor conductor of heat or of electricity as well. Okay, so conductors means it can conduct something. So it could be heat or it could be electricity. So when we do electricity, we will jump into a new whole chapter about electricity and poor and good conductors. But most of the time is about the same, except that for electricity, we will be going deeper into the atomic structure to look at what kind of electrons actually help to facilitate this electricity transfer. Okay, so that's for primary 5 and primary 6. So we start with heat first so that you are well prepared for electricity later on. All right. Okay, let's start some questions. I hope all of you have done questions. Okay, if you have not done, it's very easy to just quickly do this, because in which setup will the balloon inflate first? Okay, at one glance, it looks like it's an expansion question, but it's not. It's actually a conduction question, because the 4 bottles here are made from the different materials I just showed you. Okay, so what are they? Very good. So you found the material. So obviously the one with the best conductor will take the heat from the hot water and pass it to the air inside, and the air will also expand. Of course, there's expansion quicker, and then the balloon will inflate faster. So the first answer will be all balloons will tend to inflate, but some faster than the others. The metal is the best conductor, so therefore answer will be B. Okay. Okay, I hope you can look at your questions that you have done and go through with me. Those who have not done, it's a bad habit not to come to class, or to come to class without having done anything. I keep telling you guys to do so that you'll benefit more. Okay, so try to finish your work at least even 30 minutes before the class. You know, some of you come and sit down here early, so you just try to quickly do. It's only 6 to 7 questions usually. It's quite quick. Okay, so that you have a better idea of what's going on whenever we try to do these questions. All right. An equal amount of water at 80 degrees is poured into 4 identical cups, okay, 4 different materials. The temperature of the water in each cup is taken every 2 minutes. So all of you can appreciate the graph. And you can see all of them start from 80 degrees Celsius, right? Yes or no? (80°C). So, and then the temperature drops, okay? So which one do you think is dropping? A is a bit useless, it's not dropping at all. Something's wrong with that, okay? Then the rest are getting cooler, okay? Cup B is getting cooler, cup C is getting cooler, cup D is getting cooler. But only cup D, the temperature is dropping all the way until one certain number. So the question here on the right, the question is not the question that you got in your homework. The question is a new question that I'm asking you right now. What is the room temperature? All the cups are going down and they are trying to reach room temperature. Usually after room temperature, it doesn't go down anymore because there's no heat transfer once it reaches that, because both temperatures are equal. Once both temperatures are equal, there will not be any heat transfer. So they will reach the equal temperature of the room, with whatever room that you may be in. Okay, like I always highlight that every room that we all are in is different. So in this case, you can actually pick up the room temperature because they specifically highlight 28. And cup D is going to 28 and then it's going straight along 28 and it's not trying to go below 28. So that's why I will infer 28 to be the room temperature over here. And then the rest of the cups are trying to go down in a lot of shapes, but they will eventually reach 28 because they are, after all, in the same room. But let me slow down here and ask you one question. What is this guy cup A doing? Cup A is a nonsense guy, you know. He's at 80 all the way. He's not even dropping to 79. What's happening to him? How can something keep its temperature at 80 throughout? Tell me. You measure every 2 minutes, he's still at 80. You measure every 2 minutes, still at 80. Something's wrong, right? So maybe you can use your analytical skills, your brain, your 9-year-old, 10-year-old brains to tell me, what is this cup A all about? Why is it still at 80? How can we solve this mystery of cup A not losing any heat? Can anyone think? I have the first answer, only one. I want more answers, I'll wait. Okay, you should actively participate because after all, I'm only asking you to type in, which is not uncomfortable for most of you. Some of you love to talk, want to open your mouth. I will actually can unmute you. Okay. How about Victoria? You want? I will unmute one by one. Maybe you can tell me. Anybody? Okay, let's clear all. Okay, the first person to raise your hand now, I'll allow you to talk to me. Anish, first person.
It's made up of a different material.
Material, okay. So no matter, are you sure that, like what? Like any material also, even you put, it should exchange heat with the environment, right? Because your room temperature is 28 after all. It should lose some kind of heat. For example, let's say you put coffee. Do you think the coffee will stay hot for so long after 60 minutes? You can see that after 60 minutes, that's 1 hour. It's still 80 degrees. Okay. Yes, it's made up of probably a very, very good or very, very poor conductor, very poor, such that they actually cover, okay, they do not allow the heat to exchange. That means they not only not allow the heat to exchange by its sides, they don't allow the heat to exchange from the top, so they have to have a cover, and all this cover should be insulating this drink, whatever drink it may be, coffee, from the outside, so you can put in like air, you can make it a poor conductor and so on. And this is the principle behind a vacuum flask. Okay, so the word I was looking for is something similar to a flask. A flask tends to be able to keep the heat away from the container for very, very long because of the materials it is made of, because of the air gaps that they put in. Okay, we will also study the parts of a vacuum flask in the future, where they can prevent all the heat sources, okay, be it conduction, radiation, convection, all of these heat sources, to prevent it, to keep the heat as hot as possible or at the same temperature for as long as possible. Okay, for as long. That means for 60 minutes is 80, but it's not able to keep it there forever. We can never keep it there forever, okay, unless you constantly heat it up. Okay, you must be constantly heating it up. Similar to a fridge, right? A fridge is frozen. Let's say you put some ice inside there and you freeze it. Ice cannot stay frozen forever unless you constantly freeze it or constantly keep the temperature at zero, which is what your fridge is doing very hard. By plugging it into the electrical socket, it must be switched on. It's constantly running and running and running and working very hard, a very hard workhorse to keep the temperature at zero so the ice can always stay as a solid. The moment you switch off or something wrong with the fridge, it's not working as hard to keep the temperature at zero, then it will gain heat and start to melt. Similar to this cup A, okay, something is constantly keeping it away from the heat, or the other answer is you may be putting it on a hot plate, where the hot plate is keeping the cup A heated all the time. So you are heating it up. So imagine you are at a, you put it on the stove, there's some kind of energy, or you heat it up and constantly heating it. So you don't allow it to drop to 79 or 78. You keep it at 80 by leaving the heater on. So just like you leave your fridge on, you leave the heater on, then the temperature can be kept at 80. So that was what I was looking for. Thank you so much. Okay, for those of you who said very poor conductor, is so they are poor conductors, heat will still try to take. So the answer definitely for this, which cup is made conduct the heat the best. So this one is not poor conductor, but good conductor, and the good conductor will lose heat very fast. So the answer is cup D. Okay. Next one. Nina wanted to find out. What does she want to find out? Which is the best conductor of heat? Okay. If you see the heading here, I actually put up here, it's an analytical question. Okay. Many of you need to know in which material is the heat traveling the fastest. She's heating it all from the same side, and then the heat has to travel to the other side and then melt what? What is it? Wax. Okay, very often we always put wax because wax always melts when heat is supplied. So it's going to melt, and then once it's melted off the contact part, it's going to drop off. Okay, very similar to blue tack. You guys love to play with blue tack. Blue tack, there's only contact on the wall, right? So when the contact is taken off, obviously blue tack will drop. So similarly here, if the wax melts and there's no contact with the rod, it will melt and drop. So which one will drop first? Okay, she already measured. Nina already measured. Oh, in P, it dropped after 2 minutes. Q and S drop after 5 minutes. Not very good. It's not a very good conductor because it's very slow for the heat to pass to the other side. So we will eliminate the 5 minutes and we will take into account only the 2 minutes. So it's only P or R because P or R transfers heat very fast. Now let's look at P and R closely. P is short, R is long. So which one is a better conductor of heat between P and R? Okay, now this is time to think analytically, okay? For P, it's so short, it's obvious the heat traveled there. But for R, it's so long, yet it traveled in 2 minutes. That means he traveled faster in R because it's so long a distance, and yet he reached there in 2 minutes. Okay, it's just like to test whether you versus your friend, who is faster, right? Who's a faster runner. So if you reach a point further away, the second bus stop, in the same time as your friend reached the first bus stop, which means the person who went the longer distance is the faster person, okay, because he ran faster and reached another longer part, which just like material R. Okay, got it? So that's the analogy I can give you. You have to think analytically and not choose the shorter one, although it may be very, very tempting to choose material P, but answer is material R. Okay, so very good. Those of you found the right answer. You actually managed to think analytically. Okay, you must know the one that goes further in the same 2 minutes must be the one that traveled faster. So therefore, material R is a better conductor of heat. Mr. Lim used 4 similar rods. All these questions are very, very similar. So I'm just going to like take like 15 seconds to go through it and then tell you the answer straight away, because you can think through it later like, oh yeah, this makes sense, because you are going to go through it. So it will benefit those who have tried it and those who haven't tried it for me to go fast now, because after all, the idea here is to see how fast heat travels from the point you heat, for this example is Bunsen burner, to the other side, right? So here, they said the time for the beam to drop. Okay, you have a beam that is stuck on top of is it wax again? Yes, again it's wax. So it's very common for us to use wax, because wax will melt first. Because the wax melts, the beam will drop. Which beam dropped first? Time taken for the beam to drop, Z. Z dropped in flat 7 minutes, right? So Z transferred the heat the fastest. So Z is the best conductor of heat. So therefore, Z must be the best, followed by Y, followed by W, followed by X. So answer is bravo. See, 15 seconds, I'm done. I want to go next question. Like I said, if you're not catching me, you can catch me after the lesson by going through the questions slowly at your own time, okay? Because we can't go too slowly now, because I gather that all of you are quite clear on what's going on already. Oh, this is another type of question where there's a hot and cold water, right? Hot drink, cold water. Obviously, hot water must pass the what? Heat to the cold water, right? So we have a legend to show you. Drink X is the dark line, water is the dotted line, which is below. Now, when the heat transfer is done, the important thing to remember is that both of them will reach the same room temperature. And therefore, I look at my options, I only have one option. Both of them will reach the same temperature. One will be from very hot, come and reach room temperature. One will be from very cold, reach room temperature. Both of them sharing the heat between each other. And then they say, come, let's shake hands and be at the same temperature. So the final temperature will be the same temperature, which is the room temperature. Okay, so answer is ta-da, da, 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 d, da, da, da. Okay, next question. Everything 10-15 seconds. Let's go. Then you know that, hey, this chapter very easy. Okay, same thing here, repeated exactly the same. This time is another kind of flask, another kind of drink, but still cold water, and then there's hot coffee. Earlier they called it liquid X. Now this is what you have to be very, very happy about, because when you get a question in P3 exam or P4 exam or P6 exam, you get a question that you've seen before, and little changes like this will be made. So you don't have to worry about it at all, because you've done it. And you are so good at it, you just get the answer very quick, and you can show off to your friends to say, I know this answer, because at the end of the day, Dr. Ali discussed this 1 year in 2020, 2 years ago when I was in primary 3 and primary 4, during COVID-19 time, that heat transfer will happen and they both will reach the room temperature at the end. So which one shows reaching the same temperature at the end? Looks like A and B. But then A and B, between A and B, there's a small difference, right? The temperature continues to fall below room temperature. It cannot be, okay? It must always stop at the room temperature and must all go along the same line after that. All of them must shake hands and hug each other and say, let's go together. So which one is going together? Only B. All right? So that's why only B is the right answer. Okay? So this is how you carry out your analysis. And like I said, I made you all happy by saying questions will always look somewhat similar, the same. Don't be ever too scared about science papers. More practice means you have more questions put into your brain bank. Everything has gone in. All this has been done already. The teachers cannot find questions that are super new or super something they never see before. It's always about heating. Means there will be a rod, there will be wax, there will be water, there will be wax, there will be hot water, there will be cold water. How different can we go, right? If we just change hot water to hot coffee, does it change anything? Same thing, right? So you just know your concepts, you can answer any questions. That's why I said you guys should be very happy to do science papers. Okay, maths is a bit difficult sometimes. It can confuse you a lot more. Okay, handle made of plastic because it is a straightforward. We did this right at the start by showing you a pot with a handle. We always say there are two things. Okay, one is to make it hot, one is to make it not hot. So we try to make one is good conductor, one is poor conductor. So there's two options here, two parts shown here: metal pot and plastic handle. What's a metal pot for? What's a plastic handle for? Metal pot, plastic handle. Okay, the first question was handle first. Because it is a poor conductor of heat. Thank you very much. And the pot is made of metal because it is a good conductor of heat. So I think I should have asked you this question long ago, but this is just to emphasize that this whole chapter is about good and poor conductors. So we finally finish the whole session. Okay, we still have 10 good minutes. So what do? We breathe in and read a comic. Okay, I finished, so I laughed. I heard all of you laugh. No, I didn't. Maybe I should have like unmute everyone. Oh, some people are still requesting me to play the video that we saw at the start of the lesson. You guys came later. Okay, I will play the video before I leave so that you can actually see the title of the YouTube video, and then you can search for it yourself later also. Okay, but I will play the end of the video just to make it fun for us before we end. Okay, so stay here while we finish the lesson and then we play the video. Okay, but when I'm saying my sayonara to you, I will play the video. Clear? Okay, so this comic is about another student just like you. You are the mischievous people. Okay, your science teacher tell you to boil water. You went to take hydrochloric acid and say, teacher, water boring. I'm actually heating hydrochloric acid. The teacher will be like, hey guys, get out of the class right now. This guy is boiling hydrochloric acid. Is going to explode any minute. And then fire drill. Tring. Of course, all of us enjoy fire drill a lot, right? I was a boy before I learned fire drill because we can run out of the classroom. Why do you want to stay in the classroom? This classroom's boring. Unless our teacher is super interesting like me. Okay. Yeah, I should just go back to one of the schools, right, and teach maybe. How many of you want me to go to your school and be a science teacher? Let me know and I will apply to your school. Just kidding, come on. Okay, let's go. I was in a school before, obviously. I was teaching students. All the students that I taught are already grown up now. You know, some of them are even married. Interesting, right? So one day you will be growing up and you'll be married, and then you'll be still thinking, Dr. Ali taught me one day, and I'll still be around. Right? Hopefully, I'll still be around. And yeah, my students will grow up as time passes. My students will go to university as time passes. So can you imagine you learning primary 3 science, then one day you're already university science, and you still remember Dr. Ali, and then one day you see me on the street, like, hey, Mr. Ali, how are you? Then I ask you, and you say, oh, I'm already married. I have 2 children. Wow, I'll be like, wow. Okay. All right, yeah, but that's happened to me a lot because I do meet up with students on the street, right? I don't hide myself in the room. I go out, I see my students, and they're grown up, really. They are 25, 30 even. They have their own families now. They have their own children now, and probably soon I'll be starting to teach their kids as well. Aha, see for how long I can continue teaching. Okay, let's do some challenges. Some of you told me I didn't do last week's challenges, okay? Yeah, those challenges, I'm going to put them in a vault for a while. Maybe I'll do it next week because I have this week's challenges. I want to straight away do heat challenges. So it's your turn. Okay, we have some time to challenge you. I want to really strike the iron while it's hot. Is it strike the iron while it's hot? Is it that correct idiom? My English not so good. You guys teach me. Is it strike the iron while it's hot? Why do we strike an iron while it's hot or strike the rod while it's hot? Type to me the correct idiom, okay? I want to learn from you if your English is powderful. Okay, your turn to do some questions. So those of you who have been bored by me, these questions are unseen questions. You have not seen them before. Unless you attended my 88 tuition class online, then you may have seen it, but you may have forgotten. So I still post the challenges. I have 4 questions today. I want all answers, correct answers. If you have understood my class, then you will get all 4 correct. So shall we start? Question 1. Okay, question 1. Strike the iron while it's hot, Victoria. Thank you so much. Everyone, read question 1 and tell me the answer. If not, I will just move on to the next slide and you'll be slow. Okay, question 2 will come very soon. Just 15 seconds. Answer for number 1 is C. Okay, so because they said when the copper wire is strongly heated at a certain position, the wax began to melt in the order of W first. So W melt first, then Z. So it must be close to W and Z. So it must be C or B, and it must be closer to W. So answer is C. Very easy. I can't believe you guys cannot get this question. Okay, similar one, another one. But you see, remember I told you, your teachers cannot run away from asking your questions in a different way. It's always about wax. It's all about heating. So this one is similar to the first one. Therefore, I expect you to do it. But you know, this is the kind of question you get in your exam. Now they tell you that they are heating at X. Okay, they tell you. Earlier they asked you, where do you think it was heated? Now they tell you where it is heated, but they change the question. Top C, upside down, to balik. What does that mean? Just change the question, put it upside down, and then you ask another question. So this is what you can expect in your exam. So try until all these questions are exhausted, then you are well prepared for exam. Nobody can make you fail an exam unless you have not tried hard enough. Okay, let's go. Answer is definitely bravo. Okay, B will melt first, followed by D, because these two are the closest points. And of course, B is closer, so B will definitely be melting first, followed by D. Okay, so B, D, answer is bravo, definitely. Then between A and C, you can see A is slightly closer than C. You can measure with the ruler also. Okay, very good. Now this one, number 3. The wax on the wooden rod, wooden compared to the metal rod, will it melt faster or slower? On the wooden rod, somehow it's than the wax. So you cannot just slow or fast, you must put slower than the wax. Okay, the answer is slower. Okay, because wood is a poor conductor. Give a reason for your answer. Wood is a because wood is a poor conductor of heat. No. Those of you say poor is wrong. Because of the word, now it's English lesson. Now because of the word then, okay, wood is a poorer conductor of heat than metal because you're comparing two. Okay, so you should write poorer, not poor. Clear? Okay. Which thumbtack will drop from the rod first? Again, you see your teachers, no idea, do the same question again and again and again. Again, you put heat, again, you put wax, again, you put something, again, it will drop. Which one will drop first? Answer obvious, so obvious, B, obvious. Now you're so well trained, right? So like I said, next time you go to class, you will be the expert at this topic, no problem. All your students, because you've done this before. Why? Now we must tell why. Because it's the closest to the candle flame. Firstly, that's the data shows you that it's closest. Secondly, therefore, this wax will receive the heat first. Okay, gain the heat first or receive the heat first. So you have to tell them that's why it's going to fall off first. It's going to melt first. Okay, these are all the things that you can say. Last question. Last question before I play video. Okay, let's go play video at the end. Okay, based on the results in the table, arrange the rods in order, starting with the best conductor of heat. Best conductor, obviously, the wax must melt first, so you look for the shortest time. Now, one of the common mistakes you all make is you choose Q straight away because Q shows 15. 15 is wrong because you have to show the fastest time means shortest time means the smallest number means is 5. So S is the best conductor of heat, followed by P, right? Then R, then Q last. So why? What about? But then they all fell, right? So now the question, very important question. This one is a common question. They'll be like, Okay, you say S will fall off first, but why did P, Q, and R also fall off? You'll be like, yeah, they also receive the heat in the end. It's just that they will receive slower. They receive the heat much later or slower. They will finally receive the heat. No matter how poor the conductor is, usually they will take some more time to receive the heat. So it takes like 3 times longer. See, S is 5 minutes, Q is 15 minutes. 15 minutes later, it still melts and drops. So all of them will eventually receive the heat. So that's the answer. All the rods gain the heat from the hot water, and the wax melted in all of them. So that's why all of them fell. Okay. Okay, this is based on the experiment above. State 2 variables that should be kept constant to ensure a fair test. Okay, the only thing that you should change, you see, no matter what chapter we do, whether it's light, shadows, heat, temperature, conduction, every time there's a fair test. So again, this one is another thing that you learn, like from through my live classes with Dr. Ali. You'll be like, yeah, we always learn that fair test can be applied to any topic. You open your textbook, chapter 1, chapter 2, chapter 3, chapter 4, chapter 10, chapter 100, also will have fair test, because everything is about science means experiment. Experiment means testing. Testing means test and result. Result means you need to make sure it's a fair. If fair means you need to make sure only the one that you want to test you change, the rest you keep it the same. So here they ask you which one should you keep the same. The beaker material is the same. Which one is the one they're changing? Okay, heat conductivity of all the rods. Only the rod you change, the rest same. So don't go and change the beaker material. Don't put glass one is metal, one is wood. No, all the beaker must be same material. The water, all of them must be same temperature at the start. The wax, the amount of wax, all of them must have the same wax. The thumbtack, all of them must be the same thumbtack. Cannot put one plastic thumbtack, one metal thumbtack. Okay, so what it means is change only the rod material, the rest is the same, and you can answer any one of those that we just discussed. So amount of wax, the material of the beaker, the temperature of the water, the thickness of the rods, anything except the material of the rod. If you wrote material of the rod, that's the only wrong answer. The rest that you see must be the same. Same size of beaker, same size of this, same size of that. Okay? Okay. Who wants to see video? Okay, first, before video, some of you still want to see the joke. So I'm going to put the joke on. Oops, that's the joke. Some of you still wanted to see this joke. And then some of you still want to see the video. So I'm going to show the video in a while. Okay, just hang on. After this screen is gone, I'm going to share the video. Okay, so that will just take 5-10 minutes to finish the video. Okay, hang on. Let me just stop the video so you can see the video. All right. Okay. So that was the video that was at the start of the lesson. Okay. Now you guys saw it, and it's called Science Max. You can find a lot more cool things. See, this is the tip of the iceberg. Okay. You have a lot of cool things. This is why I watch in my free time. I show all my children, my science students, they just love him because he does things outside in the open. He actually gets to fly, he gets to do this, blah, blah, blah. You will know what I'm talking about. Next week, maybe we share with each other what videos you guys saw and share with each other. I like the one on the magnets. Go and see the one on the magnets. It's quite interesting. There's some stuff he builds with planes as well. And every one of them is about science concept. So Go have fun. I'll see you all next week. And oh, you guys don't have school next week too, so make sure you join me here. You will have some home-based learning from your school, as well as I hope to see you all back here with me, because as usual, we will be having fun right here.